Hey everyone, my name is J.R. Johnson, and my talk today is going to be a crash course for web application penetration testing. So first, just a little bit of background about me. I'm a principal security engineer at Triaxiom Security. I've got a bunch of letters up to this point in my career, including some web app related certs from SANS and OffSec. More importantly, I'm a dad to two mostly wonderful kids. I enjoy competing in CTFs with the other guys on our pen test team, and I also enjoy collecting and drinking bourbons and ryes. Um, there's my Twitter and Discord handles. If you have any questions during or after the talk, I'm pre-recording this so I can respond to any questions that come up live during the talk. So reach out to me on Twitter or Discord. And a little bit more about me. So I don't normally do this much background on myself, but I added this slide in because I think it's valuable to understand how I got into pen testing and kind of what perspective I'm approaching it from. So I spent a little over 7 years as primarily a full stack developer supporting the Air Force. During that time, I accumulated a lot of different responsibilities, things like server enclave management, certification and accreditation, that started to shift my focus more toward application security. Ultimately, before I left that job, I started performing cybersecurity evaluations for command and control systems used by joint services, which really kind of convinced me to make the full jump over to the private sector and start doing penetration testing. With that background, when I got into the private sector, obviously web applications kind of naturally became my specialty when I was working as a consultant. So, and as a lot of you probably know, when you work as a consultant that does penetration testing, you get to work with a really diverse set of organizations. And so I got to see a lot of different types of applications, a lot of different architectures over the past several years working as a penetration tester. And so during those years, and more specifically, as I was kind of researching this talk, one thing was pretty clear. People absolutely love the OWASP top 10. Every talk I watched preparing for this that was even remotely related to pen testing had an OWASP top 10 slide or was covering the OWASP top 10. And don't get me wrong, there's certainly value there, and the OWASP top 10 is important. But it's not really the focal point of thoroughly testing an application. And so that kind of led me to organizing this as a primer for web app pen testing based on my real world approach. So this is what I've used to train other penetration testers in this space over the past several years. It's what I continue to use as I do application penetration testing or as I encounter applications and other types of testing. And so just for basic background, the OWASP top 10 is not a testing methodology. It's a categorization of vulnerabilities, based on industry surveys that were sent out. So it kind of categorizes them into these groups and ranks them by impact and prevalence. And it's a good thing because it can be used to educate companies on how they can weed out those vulnerabilities in their development processes. It gives them an idea of some of these really important things they should be looking for and trying to avoid. But ultimately, as I mentioned, it's not going to teach a penetration tester how to conduct an assessment. OWASP does have a security testing guide, which they publish, which is very detailed. And it's a really great reference to use during testing. But it's more of a checklist of making sure you've covered everything rather than an approachable process as you're evaluating an application. So it's a little bit of a complex set of vulnerabilities that you should be looking for, but they're not really in a particular order where you can kind of run down the list. And ultimately, a ton of talks in this space in web application security in general focus on some really cool attacks, some relevant exploits, or things that are particular to a certain technology or stack. But these things don't apply in all situations. So one of the things I didn't find as I was looking through all of these different talks and looking for other industry resources is a more realistic approach to penetration testing, something that you can use that's more repeatable in every scenario. And so that kind of led to this talk ultimately. And so when we're going through this, why should you care? Well, first and foremost, if you're a penetration tester, the goal here is to start off with a basic repeatable approach that works for any application you encounter. This is going to be across every type of penetration testing, really. So, this is going to focus on web application penetration testing specifically, but it's got applications in network level testing where you may find an application on an external perimeter of an organization. Or internal penetration testing, maybe when you're running out of options on an internal network, so you start looking and digging into applications a little bit more. Through each of these different approaches or areas that you might encounter web applications, the goal here is to just give you a consistent approach to identify more vulnerabilities so you feel comfortable when you start looking at applications. And if you're a blue teamer or a developer, there's still a lot that you can learn from this material today. If you can understand how an attacker thinks about your applications that you're trying to defend, you can better identify the attacks that they're going to be using, and it'll help you cut those attacks off earlier in the kill chain potentially. Yes, I just said kill chain, so drink. And so a brief overview of what we're going to cover today. So I'm going to touch on what makes web application penetration testing unique, first of all, compared to the other types of assessments that are out there, and why this is a more unique problem to web app pen testing than, say, coming up with a process for an external pen test. And then we're going to talk through what that realistic high-level assessment approach that can be used is. So we'll start with planning and we'll work our way all through QA and reporting. And so, like I said, web applications are unique. So as an attack target, there are some differences and some things to consider when you're looking at them. First and foremost, web applications are important. So in more and more cases, applications represent, the primary, if not the only things that organizations are exposing to the internet. We're seeing more and more attack surface get cut off through the use of VPN or multi-factor authentication on things like VPN and email. And so attackers are focusing on other targets like web applications. In addition to that, applications are often driving the core business of organizations now. So what do I mean by that? Things like SaaS companies, companies with an e-commerce presence. The impact of application compromises can be extremely high when your business model is focused on these applications staying up, not being compromised, things like that. So overall, web applications are important. Quick statistic from a recent report I saw from Forrester on the state of application security, 42% of organizations that had experienced an external attack blamed the incident on a software security flaw. Now, take this for what you will. This is just some random statistic. I think the number might be a little high, honestly, if you had to ask me. But the point still stands. As network security improves in other ways, attackers have to shift their focus. So a lot of times we're talking about this in the context of social engineering, which is certainly still true, but this also applies to exposed web applications. And so when you're looking at a web application, typically there are some starting points for our approach that are true most of the time. If you're calling something a web application penetration test, it really needs to be an authenticated assessment. If you just do unauthenticated web app testing, it's kind of like having a home inspection, but they're just checking if the front door is locked, maybe checking around the house to see if the outside of it looks good. They're never actually going into the house. So there's so much that could be wrong inside, but you never know if you're not doing authenticated testing for an application that you're really trying to evaluate. And that's why in most cases, web application penetration tests are conducted as gray box assessments. We're given some things, maybe an application walkthrough, some credentials to authenticate as different user roles. Maybe we're given some information about the architecture or the business use cases. But most of the time, we're not going to have full access to source code. A lot of organizations will kind of categorize this as a separate type of assessment that's usually a lot more thorough. So this is not going to be kind of the norm for what most organizations can afford or what they're ready for. But what makes web app testing different given all these things? Well, first and foremost, every application you encounter is going to be different, just from the sense of the tech stack it's using, what language it's written in, what framework it's leveraging, the underlying architecture, everything from cloud architecture now to Linux versus Windows operating systems to how is it built, or how does the traffic flow through the application? Is it thin front end where there's an API you're using? What all these different things create these unique combinations, and each unique combination has a unique attack surface. So a standard testing checklist is extremely difficult when we're talking about web applications. Web applications are all going to be unique. They're all going to be different. So there's certain things that just aren't going to apply. You have to really consider what you're looking at, and how to kind of manipulate your checklist to work in every scenario. And so that's what we want to try and do here. I want to try and address some of those challenges to create a baseline, just a simple, basic, repeatable approach that you can use in any situation when you're trying to evaluate the security of a web application. And so here's what the high-level process I'm proposing looks like. So this is what I tend to use as we're going through an application. And these steps should be somewhat familiar. You can break them down in a lot of different ways, and maybe you'll want to customize this if this is something you're going to use over and over again. But ultimately, the 5 steps that we've broken this into are planning and preparation, which is basically everything you need to do before you start testing anything. Then we've got unauthenticated testing. So this is the part of testing where you're basically emulating an attacker on the outside, trying to break in, trying to gather sensitive information, anything that you can do that doesn't require credentials to the application. Then we focus on the login process. So basically everything that happens as you authenticate to the application and how the application tracks your state. So what state you're in, how it performs session management. And then the authenticated testing piece, which is most of the time going to be the bulk of your testing, but basically looking for all these different types of vulnerabilities after you've logged into the application. And finally, just hit on some things that are important to keep in mind as you wrap up with quality assurance processes and reporting for an assessment. So first, planning and preparation. At this point, you're really just getting ready to test something. So there's really nothing technical you need to be doing at this point. You need to have all the necessary paperwork in place, things like contracts, your ROE prior to getting started. There's plenty of other talks that have gone through things like this. You've got to get some target information and credentials from whoever you're doing the testing for, and make sure you understand any restrictions that are in place for your testing, any areas of the application that are off limits, what is and is not in scope. In a lot of cases, maybe you're going to get an application walkthrough from a stakeholder of the application on how they use it, just so you could kind of have a little bit more context as far as use case or what normal usage of the application looks like. And that'll kind of help inform your testing too. And ultimately for all these things, we're not going to spend too much time here during this talk. Really, this isn't the interesting stuff, so there's no reason to spend too much time here. And then there are other talks that focus on penetration testing preparation that is repeatable and things that you can do for any type of assessment. So, but with your preparation, I do want to touch on some important considerations with your tooling at this point. So this is probably going to be the most specific I get in this talk, and just talking through some of the things to keep in mind as you're getting ready to do testing. The most important tool in our toolkit as web application penetration testers is arguably whatever intercepting proxy we're going to use for the assessment. I primarily use Burp Suite Pro. I think it's by far the most prevalent at this point in my experience, and I just really think it's the best for this. But when you're using this, and these things can apply for every intercepting proxy, but you'll see my screenshots do use Burp Suite as the example. There's going to be a few tips that will help save you time and make sure you're consistent in how you're assessing applications moving forward. The first thing here is just to always start projects that are saved to disk. this is something that I've learned the hard way, unfortunately, from time to time. It's very easy to just start up temporary projects as you're testing, helps you get into it more quickly. But even if you're doing some quick checks, you're going back to double check things, it's always good to save those burp files to a project folder, just so you can go back and reference them, and then obviously clear them out over time as you don't need them anymore. But I can't tell you how many times I've gone back and had to retrieve some type of valuable information from those burp files that I wouldn't have had if I hadn't saved them. So very simple, but something that's really valuable as you go through and want to be more consistent in your testing. Additionally, when your organization finds and sets up a set of valuable configurations, so things that you guys have collected over time or things that you want your entire team to use, little quality of life changes even, these things should really be saved into configuration settings and reused. So you can export these from Burp Suite as project options or user options. And there's different options that apply to a project versus a user. So there's some slight differences there. But these things can really speed up your startup time when you're beginning a test and make sure you don't forget anything that's really important. So under project options, we use this for things like your custom burp collaborator. So if you leverage a custom collaborator such that you own the host that all of your client traffic is flowing to and from, you want to make sure that that's configured every time you do an assessment. Additionally, under user options, there's things that can just be, simple quality of life improvements to make things a little bit faster, a little bit less painful. You can change your backup frequency. So I think by default, it's something like 60 or 90 minutes. Burp's going to do an automatic backup. I think there's a lot of value in that. I like the automatic backup feature, but a lot of times I will increase that time period to something like 120 or 180 minutes, just so it's less disruptive. Additionally, things like disabling your proxy on startup so you're not automatically intercepting traffic and wondering why your web page keeps freezing. I know that's happened to me several times. Make sure that that's disabled on startup, or configuring a SOX proxy that you leverage every time you do testing. So if you have specific testing instances where you need to proxy your traffic through for web applications, you could save all that and just load that as a configuration file the next time. Also within Burp, there are some amazing capabilities you have at your fingertips with extensions. And new ones just continue to roll out that I find more value in every day. So a couple of the common ones that I use are things like ActiveScan++. This just extends all the scanning checks that Burp uses, helps to identify some things that there's value in as an attacker, but that Burp won't look for natively. So things like suspicious input transformations, host header attacks, little things like that. Additionally, beyond ActiveScan++, there's J2EE scan. This just provides some additional coverage for vulnerabilities that are specific to certain frameworks, so things like JBoss, struts, Grails. And it does provide some tools to exploit those vulnerabilities if they're found as well. So it really just provides a thin layer of extra checks that you don't really have to do anything additional. It'll just look for that stuff in the background. Probably most importantly is Logger++. So this really extends Burp's logging capabilities in such a way that makes the request and response logging more valuable. So this is really, really useful for troubleshooting or tracking responses when you're doing scanning. So a lot of times, if you're doing a scan, it's really difficult to see what kind of responses you're getting. Maybe if you're accidentally timed out or your authentication macro isn't working properly, Logger++ kind of fills that gap and gives you more ready access to burp logs. And then there's a ton of other extensions to consider just based on your target. So like I said, this isn't going to be necessarily going into some specific extensions to use for specific scenarios, but there's tons of stuff that you can use, like JSON Web Tokens is an extension that helps manipulate JWTs. Java Deserialization Scanner is exactly what it sounds like, but that will help you identify deserialization issues and then exploit those issues. And then things like GraphQL Rater, if you end up testing applications that leverage GraphQL, that'll kind of ease that process as well. So ton of random stuff. Definitely go check out the list in the Burp application store within the extender tab. Another thing to consider, so whenever you're doing testing, you want to configure your scope every time. And so this is something that is so simple, it takes 2 seconds, but you want to make sure you do this and use advanced scope control so you're not missing any subdomains or valuable information in your target tab, but you're not collecting extra additional information that you have to sift through. Let's just basically make sure that you're only seeing things that are in scope based on what you define here, and you're not getting anything extra that muddies up the information. Another thing to consider here is we need to use a browser to send traffic through burp, obviously. So we have 2 distinct options. On the left, you'll see the first option, and I'm a huge fan of it now that it's become more stable, is Burp's embedded browser. So this is very easy. From your proxy tab, you can simply open a browser. It's dedicated. It automatically proxies things through Burp. It automatically uses Burp's CA certificate. So there's really no other setup you need to do. It's the easy button. And you could still do other things in your other browsers without proxying that traffic through Burp. So if you're multitasking, doing other things, this is super convenient. If you do still want to use another browser rather than Burp's embedded browser, then you just got to make sure you have a way to quickly proxy traffic through Burp. So I use Foxy Proxy in those cases to make it really easy to turn my intercepting proxy on and off in the browser. And then make sure you install Burp's CA certificate, or else you can run into a lot of strange issues with trust. So finally, to summarize, Burp Suite Pro or whatever intercepting proxy you're using, consider some quick checks before getting started just to make sure things are going to go as smoothly as possible. So remember to save your project to disk, load or save configs so you can reuse them, be more consistent, leverage extensions to make sure you're not missing anything in your testing, configure scope so you're only seeing what you want to see within your Burp application, and then make sure you configure the browser or use a browser that will proxy your traffic smoothly. And then, profit. So this way, everything that you're doing during testing should be flowing through Burp, and that way you won't miss anything, whether you're doing a web application penetration test specifically, or other types of testing where you're looking at an application for maybe a shorter check. All right, so now let's jump into actual testing here. So first is unauthenticated testing. And at this phase of the project, our goal is to gain access to the application without using any credentials we were provided, or find sensitive information that shouldn't be exposed. So this could be information that is sensitive in nature, that may be a risk on its own, or it may help us in future attacks. And I break this down into 4 primary pieces or steps here. So the first is OSINT. Plenty of people have done plenty of talks on the specifics here, so I don't want to dive too far into the weeds of what OSINT is or how you do it. But to be honest, for web app testing, it isn't always a gold mine. So it's something to consider. It's certainly something you don't want to skip over, but it may not be incredibly valuable depending on the context of the assessment. So it can do things like provide context into the organization's business itself, maybe information about how they operate or what they use this application for. This could give you a hint as far as what's most critical within the application or what should be of biggest consideration. And it could be helpful as you're trying to determine impact and risk of specific vulnerabilities. Otherwise, it often provides hints into application architecture as well. So when you're doing OSINT, maybe you want to look at LinkedIn or job descriptions they have posted to help fill in some of the blanks as far as what application architecture you're looking at. This could give you some indication of what types of operating systems are in use, whether they use any containerization like Docker or Kubernetes. And it could fill in some of the blanks if we don't find that information at later phases. And then finally, gathering emails and usernames could come in handy. I don't always do this right off the bat unless I have some kind of target, but it can be useful if you find somewhere to launch password attacks, or if you need to consider any other types of backdoors that may be in scope for the application. try and find usernames or credentials to use there. And so next step is to evaluate the network layer. I feel like this is often forgotten or completely bypassed when you're doing an application level assessment. But I've definitely had luck here in the past. So it's really not something you should completely ignore. When you're conducting a holistic assessment, you've really got to start at the bottom and work your way up. You don't have to do anything fancy here. I'm just really talking about an Nmap scan to help identify what other ports and services may be available on the host, and then check into those to see if there's any potential attack surface we need to consider. So we're just basically checking to see if there are any side doors or back doors that may be open. And then whatever you do find from an Nmap scan, you want to manually interact with those services and try to identify vulnerabilities there. Look for vulnerable versions of software maybe. Try password attacks. If you see something like SSH open with username and password permitted, maybe try authentication bypasses or password attacks on like a Tomcat login or something on an addition on like port 8443 maybe. Any of these can help to either confirm attack or confirm architecture, of the application itself, or they could provide additional avenues of attack that we want to explore. So we've covered OSINT, we've covered the network layer, we're continuing to work our way up, and now we're starting to try and identify the application architecture itself. So this is the part where you really want to gather as much information about the application as possible and start creating kind of a mind map, understanding how the application functions and what pieces exist. Really, really simple, but I like Wapalizer as a browser add-on that basically helps to quickly identify these technologies and versions. This is like my very, very first, most basic check when I look at an application. It just automatically scrapes the page for artifacts that indicate which services or libraries are in use. It'll tell you the version numbers if it finds them. Really, really simple stuff, but can help speed up the process. In addition, so as you start making this map, or as you start mapping out the application infrastructure, you want to figure out or get a good assumption about different portions of the environment, just so you know what you're working with. And this is going to help inform testing later on in the process. So from your browser to the web server, first of all, what web server is being used? Based on that web server, do we have any indication of the OS that's being used or where it's hosted? Do we know if it's in Azure? Do we know if it's in AWS? Do we see any artifacts that could indicate they're using containerization services, like I mentioned? Beyond that, you could start to guess different parts of the architecture, right? So maybe in certain scenarios, we see a .NET application, right? That's very likely hosted on a Windows operating system because we see it's using the IIS web server. Well, we now have a pretty decent guess about, in most scenarios, what the database type will be. Probably 75 to 80% of the time, it's going to be a Microsoft SQL database being used. On the flip side, if we see other indicators, maybe that could be a guess that, it's probably not Microsoft SQL. This might be MySQL or might be Oracle database or Postgres, something like that. These little things are just assumptions we want to start trying to make. In addition, what is processing our data or request for the application? Is it being processed by the front end itself, like an ASPX page, where the front end is doing the heavy lifting and the data processing? Or is it like a thin client front end where there's really an API that's doing all the heavy lifting in between? Is that on a subdomain? What does that look like? How does that traffic flow? So we're starting to build this out in our mind. We're trying to make educated guesses or assumptions about the architecture that's in place. But beyond just the architecture itself and what types of servers are in use, what types what pieces of the application may be there, we also want to know what's sitting in between us and the web server. So these are just things that we have to account for during our testing. So this might be a web application firewall that could be killing our requests, something like Cloudflare, something like AWS's WAF. There are going to be certain things that could kill our traffic before it even reaches the web server. So if we identify that there's a WAF in place, maybe that's going to affect how our requests are processed. Is there a load balancer in place? This could tell us things like if we're seeing differences in response headers, or if we're seeing different changes to our traffic as it goes to and from the server. There may be a load balancer that's in the middle there, and that's kind of changing how it handles the traffic. So finally, when we're doing unauthenticated testing, we want to evaluate the application content itself. Once we get to the application content itself, this is, again, really we're getting more into that traditional web application process at this point, but we're trying to identify, again, any sensitive information that may be disclosed. This can be through things like directory brute forcing. Maybe we're looking at the HTTP response headers in our proxy that we've got. Maybe we see code comments that we see from the responses in our proxy. We're going to be looking at the account registration processes, forgot password processes, authentication processes, all these things that are traditionally exposed. If they're available to us, we're going to be assessing them for things like username enumeration, password reset weaknesses, password policies, and then, of course, things like injection on inputs, maybe SQLi to bypass authentication, little things like that. But at this point in that process, you're really looking to evaluate anything that is exposed prior to authenticating. And then any other vulnerabilities at this point. So, if you're scanning inputs and you see other vulnerabilities that may be based on the specific target application architecture, we want to test all those that don't require authentication as well. Moving into the login process. So at this point, we've tested the application as an unauthenticated attacker. Now we want to use the credentials that we've been given in order to evaluate the login process to get into the application. So at this point, I'm stepping through each request and response of the login event and really focus only on this attack surface. So everything where it processes my credentials, allows me into the application, and issues me some kind of cookie or token to identify my session, that's what I'm focused on here. And so when I'm doing this, it's more helpful to me to think about it in terms of what questions am I trying to answer as I evaluate it. Login processes can be so different, it's really difficult to have a specific checklist because it's going to be, you're going to kind of have to adjust based on how they handle authentication. So, everything from how do you log in, how do you log out, how do you change your password? Does the application have username enumeration that we were able to exploit? Does the application support single sign-on? So if it does support single sign-on, does it send you to a third party? Or is it an on-prem SSO? And is that in scope? That could really cut out a significant piece of our assessment here if we're not able to evaluate that single sign-on solution or how that information is communicating back and forth. Are all the functions associated with the login process encrypted? Very simple, but is anything not flowing over HTTPS basically? Are there any anti-automation tools in place? So this may require going back and forth through the authentication process, obviously, but is there a CAPTCHA that's required, or is there an account lockout that's in place? Is there anti-brute forcing where maybe there's IP lockouts? Exponential backoff, all those different kinds of things. And then if you do encounter a lockout, is it sending an email to the user, providing them a notification? Is there any evidence that there's logging of that event or anything like that? Once you get into the application though, again, session management is very, very different across the board. So is it issuing you a cookie? And if it is issuing you a cookie or some kind of token, is that a homegrown type of solution, or is it leveraging something that is built in? So something like a PHP session ID or an ASPX auth cookie, those are built in using known good libraries. So there's generally less attack surface, less to check there. But if it's something where you're not sure, or it looks like a custom solution, then you want to be looking for things like the entropy of that. Does it have cookie flags set on it? How is that session being managed? So is there a way to modify any contents of the session or token? Is there a new session ID that's issued when a user logs out, for example? And then for tokens, you have to consider any unique attack surface there as well. JSON Web Tokens, or JWTs, are becoming extremely popular as an open source standard. And so they have a lot of unique attack surface that's outside the scope of this presentation, but it's really, really interesting if you run across them. So make sure you dive into those if you see them. And then finally, jumping into authenticated testing. So the last piece of the tactical testing here. Once we've completed testing of the login process, now we basically have to look at everything else within the application. So as I mentioned earlier, this is the bulk of testing a lot of times. This is where you really got to check all the features or all the elements of an app. And this is where you're going to be looking for those exciting exploits most times. So injection points, file uploads, any type of parameter tampering, things like that. And the goal here is to, again, get access to sensitive information you otherwise shouldn't have, escalate your privileges in order to gain access to more sensitive features or functionality you shouldn't, or take over the underlying host ultimately. And so when you're jumping into testing the authenticated portion of an app, this is where a lot of people get really overwhelmed really quickly. So this is where it's important to try and have a plan and stick to it. So for me, I follow a couple rules as I'm assessing an application that are loose. It can change from time to time, but I generally focus on testing from the least privileged account to the most privileged account. And this is in order to again, focus on the things that are most impactful first. So if there's a SQL injection for a free registered user that gives you full access to the database, that's going to be more impactful than a SQL injection as an employee administrator, for example. It's also a little bit easier to sift through what functionality within the application is accessible to a low-level user versus an administrative user. I also test features in kind of the same way. So I'm testing features in order of highest potential impact for the organization. So I try and look through and understand the application. And as I'm looking through, I see what I want to target first, or what features or areas of the functionality I want to target first. So maybe I want to look at where sensitive data is stored within the application first, or how it's manipulated. For a healthcare SaaS product, EPHI disclosure is going to be really, really important. So I'll probably focus on any areas where I find that first. Whereas for an e-commerce website, I'll probably be looking at the cart first, maybe how users' payment card details are stored, or if they're stored, things like that. So you really want to adjust and focus on the highest potential impact so you can really make the most of your testing. Additionally, you may need to jump back and forth as you're testing in order to get full coverage and make sure you're checking everything. So what do I mean by this? When you log in as one user, you may need to grab identifiers, names, different accounts to target so you can check that when you're logged in as a different user. So if I want to move laterally, I'll log in as one user to get IDs or particular data that I want to try and access, and then log out and log in as a different user and check whether I can access that data. Same thing applies for when you're trying to access administrative functionality as a lower level user. If you're trying to change parameters and access features, you may not even know they're there until you log into the administrative user, and then you'll have to go back and check for them. So just keep in mind that testing is a loop. And when you're doing that, it can be hard to keep track of features for that one account has access to versus another. For most of the time for small applications, I'll do this by hand and create kind of a list of what one user can access, but another user can't. But for larger apps, you could definitely use built-in tools like Burp's compare sitemaps functionality. So you can basically browse to the application as one user, log out, browse to the application as another user and another instance of Burp, and compare the sitemaps of the two to very easily identify what one user has access to, but the other user doesn't, or shouldn't at least. And so as you're doing this testing, as you're going through all of this testing and looking for things like parameter tampering, or looking for things like, cross-site scripting, you've got to keep context in mind. More importantly here than in any other type of assessment, you've got to make sure you're looking for the right types of vulnerabilities. It doesn't make sense to look for a polar bear in the rainforest. Basically, what I'm saying here is if no input is being sent to the back end, don't bother checking for SQL injection. If there's not a templating engine in use, for example, there's not going to be server-side template injection. So many times I've seen testers that want to look for these really crazy vulnerabilities and look to take over an underlying host, but there's no file upload functionality, for example. So you're really kind of barking up the wrong tree and putting all your eggs in the wrong basket. So just keep that in mind as you're going through a web application. And then one final note here on authenticated testing. So as I mentioned, we really didn't go into any details on specific vulnerabilities or what specific issues to check for. But as you're going through and doing manual testing, you still want to make sure you're scanning with burp or whatever active scanning tool you're using as you go through, because this is really going to cover a lot of fuzzing, vulnerability checks, trying to induce useful errors that you can analyze. You still want to make sure you're doing that. And so as you do that, the important thing I want to note here is not to just click go and throw an application scan at the entire web application tree, for example. You don't want to do an active scan of every single thing in your target map within Burp Suite. Not only is this going to be really, really inefficient, but it can get really messy within the application. So you could end up masking real findings with garbage input, or you could be missing stuff. If you scan all these things at once and the scan fails, you have absolutely no idea how far it got or where the scan started to fail. Or if you got deauth, for example, you're never going to know. So you're going to be missing pieces of things. So for me, and one of the most important things I do as I'm going through and trying to scan an application is to be a little bit more selective about how I do that. So I configure my scanner. I have a specifically configured scanning profile, which for you guys, the most important thing there is just to make sure you're doing a thorough scan within Burp Suite, because that will do all of the checks for vulnerabilities, but also to aim it at specific parameters. And when I say aim it, so I'm basically looking at particular requests of interest, and I'm choosing which parameters I scan, rather than scanning all of the parameters associated with a particular request. And maybe I'll scan all the parameters once, or I'll scan certain parameters once, but on subsequent tests or when I'm looking at different requests with the same parameters, I'm only going to be looking at the ones that are of high value or of interest to me. The ones that I know that are being processed by the backend, for example, or ones that are particular fields that might be interesting. And by doing this, not only is scanning going to complete a lot faster with a lot less errors, we're not going to overwhelm the application with too many requests. Any issues we run into during scanning, we're going to be able to quickly identify them and know where to restart. Any issues we have are just going to be localized effects. And so if you're not familiar with how to do that within Burp, here's just a quick screenshot to cover it. On a request, you can see at the very top, you can just scan something broadly, and that's going to hit every single header, every single cookie, every single parameter within the request. What I do instead is I send a request to intruder, and then within intruder, I mark the specific parameters that are of interest to me. And then I scan those defined insertion points. And again, by doing this, I'm scanning in bite-sized pieces. I get results a lot more quickly, and I make sure I don't overwhelm the application. And so to wrap up our high-level process here with Q&A and reporting, so the goal here is at this point in the project is really just to make sure that every vulnerability is reported accurately, and you're giving organizations enough information to fix these issues. So again, nothing exciting or sexy here. We're really just kind of covering this for completeness, but you want to make sure you got full coverage in your testing of the application. Make sure you didn't miss any major portions or major features that could be considered critical. Beyond that, you also want to make sure you identified key strengths alongside weaknesses during your testing. You want to be realistic in how you're ranking risks for the organization. If you call everything a critical, they're not going to know how to prioritize their efforts. They're not going to know what to really focus on. So make sure the criticals are really criticals and others are just ranked lower. And then ultimately make sure all of your findings that you are reporting, regardless of criticality, are clear and detailed enough for a developer to be able to fix them. Our goal as penetration testers is obviously to create more secure applications. And if developers don't know how to go back into an application and fix these things, then there's going to be problems. We're going to see the same vulnerabilities pop back up again in future tests. And finally, just to wrap us up here, so ultimately, the whole point of this talk is to make web application penetration testing more organized and more approachable for everyone. So everybody loves to talk about the OWASP top 10, but for testers, that really doesn't do you much good when you're trying to figure out how to approach an application. So hopefully now, I know this was really high level. There's definitely room for more detail in a lot of these different sections that could be entire talks of their own. But hopefully you now have a repeatable process for any time you come across apps, whether that is with web application testing specifically, or in other types of application testing where there's a web application as part of the attack surface. And for defenders, now you have a little bit of an idea about how penetration testers or attackers are going to think about applications that they come across. All right, and as I mentioned earlier, I recorded this talk, so I will be available on Twitter or Discord at any point to answer any questions that may come up or to go into more detail, because I know this was a really small time window in to fit everything you want to know about web application penetration testing. So if you want to have a further conversation about any of these topics, I'd love to just reach out to me. Thanks everyone for your time.